right, so let's have chapter 19 for our additional math. So this chapter here is about the derivative of exponential and logarithmic functions. So first, we basically study exponential functions or the derivative of exponential functions. So let me dive in here right away. So let me give you this. Okay, so the derivative of an exponential function is equal to the exponential function itself. So it didn't change. There's no change there. Okay, why? Let me explain that. Okay, why the derivative of an exponential function is still the same thing. Okay, now the slope is the same as the function. That's the reason there. Okay, because the function value or the y value for all points in the graph is the same. Okay, what do I mean by that? So let's have an example. Okay, when x is 2, and then at this point, the y value is, okay, e squared is equal to, or maybe approximated as 7.39. All right. So this is the graph of uh, e raised to 2. Okay, this one, this curve right here. This is how you graph exponential functions, right? Now, Now, notice this point here, okay? If you want to know the gradient of this curve, basically we need to choose one point, right? Okay, and then find the gradient of that, uh, okay, of the curve using that point. And then, so we have a tangent here, which is your green line, or this is your straight line. So now finding the gradient of this tangent to the curve is also equal to the y value of the curve. Okay, so what do I mean by that? Their y values are the same. That's why uh, the derivative of an exponential function is just the same. Okay, so when you derive this, okay, the same answer, I mean, you will get the same answer for the value of y. Okay, so later we will have some examples applying this concept here. Okay, but that's the main idea behind this. Okay, why this thing it didn't change at all. Okay, so let's have one question here, applying that concept here. So for number one, let's draw the graph of y is equal to e raised to 1/2 x. Okay, so for the values of x, I mean from 0 to 2. Okay, taking intervals of zero point 0.5. So what do I mean by the first sentence? So we are going to graph this equation here from 0 to 2, okay? And then taking intervals of zero point 0.5. So this is zero point 0.5, this is 1, this is 1.5, this is 2, okay? Now, by drawing the straight line, y equals 3 minus 2x on the same graph, obtain an approximate solution to the equation this one. So e raised to 1/2 x equals 3 minus 2x. So we basically look for their intersection point. Okay, first, how do we graph this curve? How do we graph the curve? Okay, so for your curve, you're given y is equal to e raised to 1/2 x. Okay, so if x is 0, what is y? Okay, you just substitute 0 with x. Okay, so if x is 0, y is equal to 1. All right, that's why we have this point here. Okay, and then uh, if x is equal to 1, what is y? E raised to 1/2 times 1. All right, so it's 1.65. Okay, so that's why this point here. So this is, wait, let me write this. So this is 1 and 1.65, and this is 0 and 1. How about this point here? So basically, it's x equals to 2, right? So y is equal to e raised to half of 2, or 2.72. Okay, so this is uh, 2 and then 2.72. Okay, so and then you just draw a curve connecting those 3 points. Okay, so guys, do you have any questions on how I graphed the curve? Sec 4, do you have any question? All right, I think that's relatively easy. So you just complete the x and y's. So to get those points, and then plot and trace those points by making a curve. Now, how do you draw this straight line? Y is equal to 3 minus 2x. All right. So it's the same thing, class. So you use 0, 1, and 2 for your x values, and then just plug it there. So if x is 0, what is y? Y is 3, right? So that's why you have this point right here. Okay. Now, if x is 1, what do you think is the y value? Hmm? It's 1, right? This one. Okay, that's your second point. Okay. And then what if y is uh, 2? It's -1, right? But okay, it's supposed to be here, but okay, so but it's not needed. Okay. But if you graph that, there's another point here. Okay, and then you can extend your line. But basically, this is what we need. Okay. So you get the idea there, class, on how to plot the straight line. Okay, so these are our values, 0, 1, and 2 only. Okay, so basically, this is their intersection point. Now, uh, there's no exact value of their intersection point or their solution. That's why it says they're approximate the solution. Okay, so here, if I'm going to approximate by using a millimeter block, because it has a more precise way of showing the exact location of yes. All right. So for the solution, so this one, okay. So let's say this is, look class, this is 0.5, this is 1. So I'm approximating that your answer is 0.75. Okay, so that's the solution for this question. Okay, it's their intersection point, this one. Okay, so let me write here. So therefore, an approximate solution to e raised to half times x equals 3 minus 2x is 0.75. So that is your answer. Okay, so it's just an approximation, class. So use the wavy line, so 0.75. All right, so since you don't have any millimeter block there, so I'm going to move on to derivatives. But then tomorrow, I'll give you 1 or 2 questions about graphing curves and lines. So guys, do you have any question before we move on? Okay, so if there's no question, please go to page 410, and then let's talk about the derivatives of exponential functions. Now, there are only 2 rules, which is exactly, I mean, almost the same thing, okay? So in here, so the derivative of an exponential function, uh, okay, with u as a function of x is equal to the same thing, and then you need to derive the exponent or the index given. Okay, so still e, but then this u needs to be derived at the end of the answer. And then for the next one, okay, so e raised to ax plus b, okay, uh, is just the same thing, okay. So a here, this coefficient here, if you remember your sign, and then ax plus b, this coefficient here is multiplied with the identity. Same goes here. It's just that this is an exponent or exponential function, okay? So this a here will be multiplied in front of the natural logarithm, okay? So e, this one, okay? So that's, and then just write the expression again, ax plus b, all right? So let's have some questions applying these concepts, okay? So here, so we have letter A. Let's differentiate the following. All right, so what if we have e raised to 5 minus 2x? Okay, now again, it says there that if you have uh, if you're given e raised to u, and then u can be any function of x, that is equal to, okay, e and then u again, just write the same thing, but then you need to derive your exponent or your exponential function here. Okay, so that's what I did here. So deriving this, so you need to write the question again. So e, u here. So you need to write this again, this one. And then you need to derive your exponent, your expression here, which is this one. Okay, and then simplifying this, so bring down this. So answering this one here gives me a -2. All right, so everyone knows that, -2. And then just simplifying this, my final answer is -2 e raised to 5 minus 2x. So do you have any question about letter A? Sec 4? Anyone?
It's kind of confusing for me.
All right, so let's explain this thing again, okay? So the derivative of an exponential function, and then, okay, you see this u here is an expression. Okay, in this case, your u here is 5 minus 2x. Okay, so you basically write the same thing again. Okay, write the answer, I mean the question again here, and then the different thing is you need to derive your exponent or the expression that you're given. Okay, so for example, you're given this question, right? Now, the derivative of this is again, just write the whole thing again. And then you need to get the differentiation or the derivative of your exponent or the 5 minus 2x. Okay. And then bring down this and then get the derivative of 5 minus 2x. All right. So the derivative of 5 minus 2x is a -2 only. Oops. All right. So you just multiply this. That's why you get -2 e raised to 5 minus 2x. All right. Maybe let's have another example. Okay. Now let's have letter B. Now for letter B, okay. So again, you're given e. Okay. In this type of questions, you will always see this letter e. Okay. And then your u now or your exponential value is x squared plus 1. Okay, so this is your u. Okay, and then later on, we need to get the derivative of u. All right. Now, if you're confused, there's another way of doing this. All right, but I will explain this again. I'll share with you guys again later. Okay. So let me finish this one. Okay. So again, the derivative of e raised to x squared plus 1 is equal to the same thing again. So e raised to x squared plus 1. And then you need to get the derivative of your exponent, which is x squared plus 1. Okay, so simplifying this, bring down e raised to x squared plus 1. And then what is the derivative of this? Oh, it's 2x, right? So just combine both of this. That's why you have 2x times e raised to x squared plus 1. Now, what is the other way of doing this? All right. Okay, so let's have e raised to x squared plus 1. All right. Now, this here is your u, right? So u is equal to x squared plus 1. All right. Then right away, you get the derivative of u. So what is the derivative of u? So that is 2x, right? So applying that, so getting the derivative of uh, e raised to x squared plus 1 gives you, again, write the whole thing, write the question again. And then, what's the derivative of u? 2x, just that, and then that's it. So it becomes 2x e raised to x squared plus 1. Okay, so you have this, I mean, the same answer, of course. So again, there are two ways. So you can use this one, all right? Or in this case, on the second uh, method, you can identify right away your u or the value of your u, which is this, and then getting the derivative of u right away, and then just plugging it at the end of the derivative. So again, the derivative of this is equal to the same thing times, okay, the derivative of u, so times that. So that's why you have this thing right here. So it's up to you if you want to use the first one or the second one. Okay, because the main difference here is that the first one uh, evaluated or took the derivative of u while you're doing the whole uh, answer. Okay, but here, okay, just like what we're doing for product and quotient rule, we identify what is u and then getting the derivative of u. So it looks easier on this one because you just plug it here at the end. All right, but basically they're the same thing. Okay, so that is letter B. All right. So can you please go to page 400, 412, class? So for letter A, you're given e raised to half of x. Okay. So the derivative of this is the same thing. All right, it's the same thing times we need to get the derivative of the exponent or the function. All right, so that is 1/2 x. So what I did here is to get the derivative of half of x. That's why I got here e raised to 1/2 of x times 1/2. Because when you get the derivative of this is 1/2, right? And then just multiply the two. Therefore, your answers, or maybe your answer is this one or this one. Okay, but they're basically the same thing for letter A. Okay. Thank you, Tricia and Tiffany and Leo. Okay, I think you guys got the idea now, yeah? Right. Okay. So let's do letter B now. Wait. Okay, 2 more minutes. SL, Justin, and Rafa. 2 more minutes. And then the rest of you, if you want to maybe take a break for 1 minute or 2 minutes. So, let me do some extra. Actually, class, if you get the hang of this exponential function, you'll see that if you have this half here, you just multiply it in front of the exponential function. Okay, I'm just doing this just to explain it. But then, if you get the hang of this, you see the coefficient of x here, which is 1/2. We just multiply this in front of the exponential function. Okay, that's why you have this answer here. Okay, I'll look at my explanations with my previous examples. Okay, again, okay, look here at letter A. So you see this -2 here. Because this is the coefficient of x, this -2 here will be multiplied to the what? To the exponential function. So that's why you have -2 here. Look at your answer. Just that, right? So you don't have to do this process here. And then look at letter B. Mhm. Letter B, it's a different kind, okay? Because this is x squared, right? Okay. That's why I was explaining something like this, okay? So if it's an x squared, you cannot apply this one here. You need to get the derivative of x squared plus 1. Okay. So we only apply the shortcut if there's no exponent here. It's just like linear. Okay. But if it's quadratic, of course, you need to do some extra step here. Okay. Yeah. So Esel, Justin, and Rafa, I'm waiting for your papers. All right, please hurry up. 8:37. So anyway, let's have our questions. Letter B. So what's your answer for letter B here? Okay, so since this is linear, there's no exponent, yeah, in our expression here, we can simplify this. Okay, you see this 4 here, this 4 will be multiplied in front of the exponential or the e. So it becomes 4 times e, then 4x minus 1. Okay, so that's your answer. Okay, now for maybe if you want to use the long method that I just taught you, okay, so again that gives you, this is another way. So just write the whole thing again and then get the derivative of 4x minus 1. So it's 4x minus 1, and then what's the derivative of 4x minus 1? It's 4. That's why, yeah, you'll get the same answer. Okay, so that's for letter B. How about for letter C? For letter C, I think it's automatic now. So this is Again, this is your coefficient times here. So it's a negative 2 and then e. Okay, and then just write the whole thing again. So e raised to negative 2 of x. And negative 2x. Okay, so yeah, that's your answer for letter C. Okay, and then how about letter D? Hmm. Letter D, what is the coefficient of x here? It's a negative 7, right? So negative 7 will be multiplied here. Okay, negative 7. And then just write the whole question, 2 minus 7x. Okay, so that's your answer. Okay, okay. And then letter E. Now for letter E, okay, I did some extra, so this extra work for me. So getting the derivative of each term. So the derivative of this is this, right? Again, coefficient of x times e. That's why you have 3 here. And then just write this thing again. So that's it. And then we know that 7 is 0. So that's why this is your answer for letter E. And lastly, for letter H, this is different because we already have a number in front of E or before E. So identifying the coefficient of x, which is negative 5. So negative 5 times 5, right? So let me write that. So you already have a 5 here. And then this negative 5 will be multiplied here. So we have a negative 5 and then e raised to 3 minus 5x. So therefore, your final answer is a negative 25 times e raised to 3 minus 5x. So this is your answer for letter H. Okay, so I think everyone got their answers right. Do you have any questions, class, before we go to another uh, type of questions? None? All right. So let's go back. Maybe I only have one or two examples. Okay. Okay. So let's go to letter C. Let's go back to page 410. Letter C. Okay. So letter C here. So we're given e raised to x plus 1 and then cube. Okay. So here, this is chain rule. Again, an expression inside brackets and then you have an exponent outside. So this is chain rule. So your u is e raised to x plus 1 and then your n is 3. So this is the format, class. So, okay, so 3 here is your n and then e raised to x plus 1 is your u. So what I did here, class, is to identify my u first. So my u is equal to e raised to x plus 1. And then what is the derivative of my u? So it's just e raised to x. Okay, there's no question here, yeah? And then, so getting the derivative of this, okay, so getting the derivative of the question, so 3, this 3 here will be multiplied here. That's why you have 3 here. Okay, and then this is u. So I just copied this. And then why is this 2? Because this is 3 minus 1. That's why this is 2. And then what is the last part? It's the derivative of u. So what is the derivative of u from here? So it's e raised to x. And then just combining this, your answer is 3 times e raised to x times e raised to x plus 1 times, raised to 2, this one. Okay. So again, if you're given chain rule, I suggest, yeah, this is the chain rule. You identify your u, which is the expression inside the brackets. So your u is e raised to x plus 1. And then right away, get the derivative of u, which is, in this case, e raised to x. So when we answer this question, so we just substitute everything here. Okay, so what is n? N is your exponent, right? So that's why you have 3 here. And then u is, yeah, this one. This is your u, right? Okay. And then why is this 2 again? Because it's n minus 1. It's 3 minus 1. That's why this is 2. And then, lastly, you need to get the derivative of u. So times the derivative of u, which is this one. So we just plug everything here. And then it's easier for us to answer everything. Okay? So that is the chain rule. That's letter C. And then, okay, let's have letter D. Now, letter D is product rule because you have two different uh, terms here. So you have e raised to 2x and then times sine x. So again, this is product rule. So this is your formula for product rule. So what is u? U is e raised to 2x. So getting the derivative of u, we know that we will get 2 times e raised to 2x. And then your v is sine of x. And then getting the derivative of v is cosine x. Do you have any question on the derivative of u and v? I think it's understood, yeah? Okay. So what do we do? So after this, we just plug everything in our formula. So again, u is e raised to 2x. Okay, and then what is the derivative of v? The derivative of v is cosine x. And then plus, then v, what is v? V is sine of x or sine x. And then times the derivative of u. The derivative of u is 2 times e raised to 2x. And then just simplify this class. Okay. So after you simplify this, you will get this expression here. So what did I do here to get my final answer? So I just factored out e raised to 2x for both of the terms. So it's common factor, right? Common factor. Then this divided by this, you will get just cosine x. And then this divided by e raised to 2x. So you're left with 2 sine of x. So it's like we just remove the e raised to 2x. So that's why you have 2 sine of x. So that is your final answer, letter D. Do you have any question? Hmm. So we are doing exponential and trigonometric on this question here. And then for my okay, maybe last two examples. Okay. So basically, this is quotient rule because this is a division. And then this is your formula again. So you identify your u and then your v, right? So my u is e raised to 3x. So what is the derivative of that? So it's basically 3 times e raised to 3x again. So again, this one multiplied here. That's why you have 3 here. And how about your v? V is 1 plus 2x. So what's the derivative of this? This is simply 2 only. And then plugging everything in our formula here. So v is 1 plus 2x. Okay. And then the derivative of u is 3 e raised to 3x minus what is u? U is e raised to 3x times the derivative of v, which is just 2. And then your v squared is 1 plus 2x squared. Now, some might ask, do I need to expand this? Okay. For this one, you don't have to expand this expression here. Just keep it as is. Okay. So let's just simplify our numerator, the top part. Okay, so what I got here is this one multiplied here. That's why I got this. And then this one. And then again, class, so in my numerator, I factored out e raised to 3x. Okay, so that's a common factor. That's why this divided by this, if you remove this, you get 3 plus 6x. And then this divided by this, you'll get minus 2 only. So remove this, so it's just minus 2. So simplifying this further, you will get your final answer. So e raised to 3x times 1 plus 6x. Right? So do you have any question, class, for letter E? No question? Okay. And then last example, okay, which is uh, simpler compared to the previous two questions. This is my last example today. So we have 3 times e raised to 2x cubed. And then this one is over e raised to 7x minus 2. Now, you don't have to apply quotient rule here. Okay, why? Because later on, we can just put this, okay, on top. Okay, what is the main difference? Why we don't have to apply quotient rule here? Because, look, we have similar terms here. We have e and e. So we can just put this on top and then change everything here with negative, right? Unlike here, if you're using quotient rule, because you don't have any common term, right, on your numerator and denominator. That's why in this case, for letter E, you really need to apply quotient rule. However, again, on letter F, since you have common terms, E and E, so we can just put this on top by changing the signs, right? So what do we do in answering this? So we distribute this. That's why you have 6x. And then what did I do here? So this here, okay, so you subtract this because you have similar terms. So it becomes 6x minus 7x minus 2, this one. Okay, if you still remember this, okay. Again, let's say you have x raised to 5 over x cubed. This is equal to x raised to 5 minus 3, right? You remember? So this is x squared. So again, if you have similar terms, you can subtract their exponents in a division. Okay, so that's what we did here. So therefore, simplifying this, you will get 3e raised to 2 minus x. Okay, so, and then this is what we are going to derive. So getting the derivative of this, okay, here, so you will get what? So what is the coefficient of x again? It's a negative 1. So negative 1 is multiplied here. That's why you have a negative sign here, or maybe negative 1 if you want to write 1. Okay, and then simplifying this, your answer is negative 3 times e raised to 2 minus x. Okay, so that is letter F. Okay, so do you guys have any other questions regarding the derivatives of exponential functions?